Hello, everyone. We're glad to have today with us Ian Hussey, who is a senior lecturer in digitalization of psychology at the University of Bern. His research focuses on quality management in science, forensic meta-science, and measurement practices, and he also co-leads Error, a bug bounty program for science. So welcome, Ian, and thank you for being with us today.
Thank you very much for having me. Uh, just for the recording, due to an unavoidable flight change, I am having to give this lecture from an airport. So I really apologize if the sound quality or any other part of the experience isn't exactly what we planned for, but we'll do our best. It's a great pleasure to be able to talk to you today. Uh, I have given a version of this talk before, and this is a slightly more condensed version because of the time. Um, I welcome your feedback afterwards. So I'll talk to you about taboo topics that I think we can no longer avoid afford to avoid: error, negligence, recklessness, and fraud. So as a quick retrospective, I'm sure many of us are familiar with the replication crisis over the last 15 years or so. And I think it's very interesting to think about the parallels here in what initiated it and the changes it has evoked, right? The replication crisis was initiated by things like absurd claims that were made using modal research methods, the invention of terms like p-hacking, the widespread public failures to replicate findings, and it evoked many changes in our modal research practices in psychology and also in other fields. But there were also other key events um, that initiated and occurred around the start of the replication crisis that get much less attention. Things like high-profile cases of fraud. For example, Dietrich Stapel, who was dean of psychology in Tilburg, as far as I remember. And then it turned out he had been making up, completely inventing his data sets for decades and admitted to doing so. And this has evoked far fewer changes. When I talk to people over the last 10 years or 15 years, and when I was doing what mostly would have been open science work at the time, when the discussion topic turned to the issue of fraud, we mostly just had the familiar refrain that outright fraud is very rare. We have fewer prevalence estimates of it. Instead of knowing that 36% roughly of psychology studies replicate, what percent are fraudulent? We don't know. So I think this has always been a PR position and not an empirical claim. Our estimates for the rate of things like fraud are quite poor. And I think it's now time that we ask ourselves in the mid 2020s whether this PR position is still well justified and whether it's still serving the greater good or whether we should interrogate it more deeply. So these are some common beliefs that I have acquired over the last 15 years, which I think it is useful for us to think more deeply about and question. These common beliefs that research fraud is extreme in the form it takes, that it's a useful term in the first place, that it's rare, and how detectable it is. And that's what I'm going to talk about during this presentation. I'll try and go through some of the content a little bit more quickly, and then we'll have more time at the end. So first, the idea that fraud is extreme. This was definitely the intuition I came in with, and it is the picture painted by many high-profile cases of fraud or alleged fraud. So the known cases tend to make it sound very extreme. Dietrich Stapel made up entire data sets for many, many years. No studies occurred in the first place. And then alleged cases of fabrication or altering data, such as those allegedly involving co-authors, including Ariely, Gino, and others, and I choose my words carefully, um, seem to involve the apparent fabrication of big portions of the data set, like two-thirds of the data set is made up. And so that was the kind of archetype I brought to the idea of what does data tampering and fraud look like? But there are very small hints. I apologize again for the noise. There are very small hints. Chris Chambers talked about it in his book. Nick Brown has tweeted about it, that very little might actually be needed if you're willing to tamper with data sets or change them. And so I've been working on a paper that's an analogy to the Stefan and Schoenbrod paper, the Compendium of P-hacking Strategies. So instead of stopping short of fraud of only questionable research practices and not unquestionably bad ones, where the like is done in that p-hacking literature, we could instead ask, well, what if we were willing to fully make things up or change things? What forms would this take? I can think of a few. I'd be happy to hear of others. Data fabrication is when you make up totally invented new participants. Data replacement might be in replacing real ones with these fabricated ones, or duplicating legitimate participants, so to increase your apparent sample size, or duplicate favorable cases to offset ones that you have. So you say that the control condition is the intervention condition minus 5 points or things like this. Cases of fraud have been exposed because people had not removed their Excel formulae where they had done exactly this. And then dropping. And dropping is the marginal one, where it's not a justified exclusion of outlier strategy, but simply, as you can see in the plot there, the red dot in the control condition is the lowest control participant, and the red dot in the intervention is the highest intervention participant. And imagine I just kept dropping these participants from each side of each condition until I, by definition, must hit statistical significance. That would be another case of what sort of tampering could occur. So I've run some simulation studies on this. Oh, and I choose that last one because it happens in real papers, right? This is what these authors of this Nature paper admit in their correction notice to have to having done, but it was written off as a case of questionable research practices as opposed to something that to me is indistinguishable from fraud, because it will always produce significant results. So I've run some simulation studies on this of different tampering strategies across different sample sizes to ask what percentage of cases need to be tampered with to inevitably reach, or in the median case, statistical significance. And it's scary to me because in larger sample sizes, it's as little as 2% of participants on average need to be dropped to reach statistical significance. And then in smaller samples, it's proportionately more, but it's still very few cases of participants. And I think this is a slippy psychological slope for people. If we characterize fraud as people making up entire data sets, but actually only one or two participants here or there need to be dropped or very slightly altered, I think that's a much lower boundary for researchers to engage in, and therefore might make it more prevalent. Okay, next. Fraud, is it even a useful term? Well, I've been using it for the first few minutes of this talk, but let me be very clear that I actually don't think that it is. I'm not actually interested in fraud. It's a nice way to fill seats for a talk like this, and so I throw out the provocative title. But I am not actually interested in fraud. And let me clarify what I mean. In the last 15 years, discussions of intent of researchers have consistently derailed discussions about it and held us back from um, genuine scientific progress at times. Even the term p-hacking has been loaded from the start because people preferred questionable research practices over p-hacking because they said, well, it implies intent on the behalf of the researcher, and that's just not that useful. The same goes for fraud. I think it falls into this false dichotomy of honest error versus intentional fraud, as if there is a clean line between them of intent versus no intent. And what's very, very useful and important to understand here is that recent summary papers on research integrity violations and the legal frameworks that we use to understand these things don't use this binary distinction. They instead talk about work that is fine and legitimate good versus the involvement of negligence, recklessness, or intent. So intent is, yes, sort of um, preparatory acts that demonstrate that this person intended to do this, whereas recklessness is a failure to adequately prepare to avoid negative outcomes that you should have done. It was your professional responsibility. And negligence is, yeah, a failure to prepare or to look into the fact that these things could occur. And I think this continuum is much more useful to think about. And that's for two reasons. One, all of these, by contemporary research integrity standards, are research integrity violations. So we don't need to busy ourselves with differentiating between intent and everything else. And that's the current boundary of acceptability in science. Instead, we should be asking, is the underlying science, does it have is it a correct record of what occurred and what we should believe? I am interested in the integrity of the underlying science and not in indicting researchers for their practices. Um, so I think it's also useful to bear in mind that this is not the line on the right, the current boundary of acceptability in science, is not the boundary of acceptability in most professions. You can get your medical license removed for negligence alone. You didn't need to intend it. You can get your law license removed for negligence alone. When I ask people, when I ask academics, do they consider themselves professionals? They universally tell me yes. And yet we don't currently, and this is an uncomfortable truth, hold ourselves to the same standards. Because for us, in practice, the boundary of what's acceptable or not so often boils down to intent and not the integrity of the underlying work. So in future, and for the rest of this talk, I'll be clear, I don't really care about fraud or intent. The integrity of the scientific record is agnostic to this intent, and we should talk about this more umbrella term of untrustworthy research, agnostic to intent. Cochrane sometimes calls it untrustworthy work or problematic work. Okay, the next point is it rare? This is the familiar refrain that, outright untrustworthy or fraudulent work is rare. And I have no idea whether it is or not. It is worth bearing in mind that this choice or uh, this, whether it's a choice or not, the action of conducting low quality, untrustworthy research would be the rational one if, according to philosophers of science and computational simulation studies, it would be the rational choice and therefore a relatively high prevalence if the rewards for doing this in science were high, if the risk of detection was low, and if the punishment was rare and light. Now, this is uncomfortable for me because these accurately describe the current academic system that we work in. So instead of appealing to scientific principledness and what should be the case, if we take an is argument and not an ought argument, all of the ingredients for low quality work occurring at some non-negligible rate seem to already be in place. And so we need to take it seriously, I think. This isn't just my opinion. We should listen to senior folk who and larger bodies on this point. And I think one source to listen to is editors of leading journals after they step down. Richard Horton, editor-in-chief of The Lancet at the time, said, much of the scientific literature, perhaps half, may simply be untrue. Marcia Angel said that it is simply no longer possible to believe much of the clinical research that is published or to rely on the judgment of trusted physicians of authoritative medical guidelines. Somebody with friends and aging parents who need more medical care, this scares me. Right? It goes well beyond my field of psychology, and it makes me think about the care that people in my life and myself get. The Lancet has recently created a commission on research integrity where they state there is a clear crisis of research integrity and that urgent action by all involved is needed. Various other folks point about this, about problematic trials contaminating our evidence ecosystem and the like. And I give these examples in medicine because, yeah, that's the one where lives literally are on the line. So as I said in the abstract for this talk, having spent lots of time thinking about it in the last 15 years, it is very strange to me that science, despite being the industry charged with the generation of truth, has so few quality assurance mechanisms. Now, without wanting to offend any Italians listening by implying that Barilla is indeed pasta, but let's assume that is the case for the moment. It is bizarre to me that there are more quality assurance mechanisms that this box contains what is arguably pasta and that it does not contain not pasta, contaminants of certain amounts or degrees or certain types. There are more quality assurance mechanisms there than there are to ensure that this scientific article contains science and does not contain not science, right? I have to be told exactly what is in this box of ingredients and that the weight is right and the measurement of that weight is right and that it does not contain animal contaminants or chemical contaminants beyond certain levels. And these things are tested rigorously and publicly, and there's accountability within that system. What is there for the scientific article? Far less. Why do I pick on this, or what can I rely on for this? And why do I pick on this specific article published in Science? Well, very simply because it didn't occur. This Lacour paper claimed to have conducted face-to-face interviews with, I can't remember, was it hundreds or thousands of individuals around the United States? And when somebody started asking, where did you get the budget for this? It turns out the study never occurred in the first place, but it passed through peer review to be published in Science. And that was stunning to me, and it no longer is. And I think this is worth thinking about. It is no longer stunning to me because I have realized that science currently has no immune system for problems like this. The editor-in-chief of the BMJ, within the last 2 weeks, after they had a scandal of apparently fraudulent, entirely created, or at least some of the data was duplicated or tampered with. And in his editorial, he said that we rely on the good faith of authors and their institutions. Peer review is not designed for this. It starts with the assumption of good faith of authors and it builds from there. And other leading editors and institutions have said the same. The editor-in-chief of Nature a few years ago said that she would not like to think of her peer reviewers of papers as some kind of police squads catching mistakes. And I might agree with the sentiment of avoiding police analogies, but let's just dodge over that word. I would not like to think of my peer reviewers of papers as there to catch mistakes. That makes me uncomfortable. PNAS similarly says to its instructions to reviewers, the purpose of peer review is not to demonstrate the reviewer's proficiency in identifying flaws. And I sort of understand the sentiment that it should be about the research and not people really enjoying tearing papers to bits. But surely it should, to some degree, be about identifying flaws. So this is why I think we lack an immune system for this. And if we lack this immune system and we have this, the operating conditions, the ingredients necessary for untrustworthy research to be prevalent, we should ask, when we do look for problems, at what rate do we find them? And this type of research has only started occurring at scale in the last 7 to 10 years, if even. And I think it is only really gaining pace in the last 2 or 3. And that's why it might serve to define sort of, if the 2010s was about replicability, I think the mid-2020s, the next few years will really be about trustworthiness. So if this was an in-person talk, I might be able to be more interactive here and do some back and forth with folk about whether they know these papers and what percentages occur, but I don't have the luxury of an audience in person. So I'll just go through it more quickly. In psychology, what is the rate of conclusion-changing misinterpretations of non-significant p-values? 72%, as in, where a non-significant p-value is reported, in what percentage of cases is it incorrectly interpreted? The majority. What about the rate of impossible p-values? As in, when you recalculate the p-value from the test statistic and the degrees of freedom, does it change from being significant to non-significant or vice versa? Michelle Naughton showed that this was about 13% of cases in psychology articles in the last few decades. What about impossible means and standard deviations that require extensive corrections, which James Heathers came along a few years later, last year, I think, and said what he meant by that was uh, what they thought were cases of fraud. Um, but they were worried about the legalities at the time of saying so. So this involves things like the grim and the grimmer check, which I will come back to, saying, is that mean possible given this sample size? He says in 13% of cases, as in 13% of articles that they were able to check for grim errors, they found problems. And when they went digging deeper, they found serious research integrity issues. And these were in leading journals. So these are, at minimum, they give me severe pause for thought about what is happening here, because apparently we aren't checking. It's not limited to psychology. Rene Arquez, um, I think I mispronounced his name there, but recently published a very interesting systematic review of animal studies and on subarachnoid hemorrhage. This wasn't your typical current systematic review because what they also did was they looked at the rate of image tampering in those studies. And what they found was 40% of studies involved had severe image tampering problems, and 8% of those articles they have now had retracted. After reporting to the journals, um, those journals are then elected to retract 8% of those in the systematic review. And this is only so far because retractions take time and there are procedures and processes involved. So this could raise even higher. So are these isolated instances or what has changed? Well, again, in an in-person setting, I would usually at this point play a clip from The Big Short, one of my favorite movies, and have Ryan Gosling explain this instead of me. But the audio doesn't work as well on a Zoom call. So I'll cut to the key quote, which is, what was different that allowed in 2008 and around the financial crisis, a small number of outsiders and weirdos to spot something by doing something the others never thought of? They looked. And I think there's a strong parallel to science here. The thing that is changing is that we are not assuming um, full good faith on behalf of authors anymore. And instead, we have to not merely trust, but also verify. And once we start doing that, the rates of these problems start to dramatically increase, as we've seen. So, how can we do this type of detection? To what degree is untrustworthy research detectable, and how can we do this via parallel systems verification? I would say there are no easy answers here. Um, Existing incentive structures that we have are deeply entrenched, and there are no trivial answers here, but we need to try something. Much progress was made in the last 10 years, right? We are attempting every day to move beyond just running original studies to run more replication studies using the usual processes of pre-publication peer review to try and ensure quality, using open science innovations like pre-registration, like data sharing, like encouraging replications to occur more frequently. These are augmentations to our existing systems of verification where the credibility of the core claim can be updated because of the existence of pre-registration, data sharing, of replications of their results. But we need more than this. And more importantly, we have to think of it in terms of how we can conserve and efficiently deploy the resources we do have. I often hear the sentiment that we need to massively improve pre-publication peer review. But so much of it occurs, and we're already facing, by many editors' estimations, a peer review crisis. In the last decade, there have been, by my count from the Crossref database, 645,000 articles published, each of them peer-reviewed. So making this process 2 or 3 times more difficult or complex is very difficult to scale. And equally, we need to think about resources when we ask with replications which studies should be replicated, when. It is a overly resource agnostic argument to say, well, we should do all studies. Every study should be replicated and more deeply peer reviewed. With what resources? These are the questions that keep me up at night. One proposition is that we engage in these trustworthiness assessments, that we enhance the rate and the quality of post-publication peer reviews, and that we engage with these more forensic meta-scientific approaches to doing things. Verification studies, of course, talked about in open science circles as well, but not occurring at a great rate at the moment, right? Registered reports are fairly popular now, relatively speaking, but verification reports still very rarely published. I've published one of what I think is maybe one of a dozen total studies. So I think we need a lot more of this as an intermediary step, and one that is efficiency focused. Both Andrew Gelman and co. and myself and Jamie Cummins have made this argument recently that instead of trying to front load a lot of these efforts pre-publication to say the peer review before publication needs to be massively improved, what if we were to say articles reaching a certain threshold of citation or other metrics of other research relying on them, they are the papers that would be worth revisiting to assess their verifiability and their trust. So when I looked at of those 645,000 articles published in the last in psychology in the last decade, only 1,400 of them have more than 30 citations per year since publication. This illustrates the sort of the very skewed distribution of citations, right? Some articles are load-bearing publications that they attract a disproportionate amount of citations, so more work builds on it. And if I had limited resources but wanted to scrutinize a subset of articles, these are the ones I would look at. These 0.32% of articles that attract nearly 10% of all the citations. And sampling even 100 of those would be a 7% sampling rate of the population of articles, which would give us quite good estimates of the reproducibility of this work. So this isn't just an abstract idea. This is what Error is trying to do. Error is the project we run out of the University of Bern, myself, Ruben Arslan, Jamie Cummins, and Malte Elson. Ruben's also at Witten. Error is a bug bounty program for science, and it is intended to be a test bed for the alternative parallel systems of verification. We are now using these citation-triggered reviews to invite people to the program. What is it? It's a bug bounty program. So it offers paid, consensual, and blame-free assessments of highly cited articles. So the authors of the original paper and the reviewers of it are paid for their time, and then bonus payments are paid out contingent on the errors that we find. So the more error-free the original work is, the larger the payment to the authors. The more errors found, the more paid out to the error checker. We borrowed this idea of a bug bounty program from the tech industry, basically. It's very important to us that this is a consensual process to assess the sort of community tolerability of doing something like this. And it's also blame-free. So we're not interested in skewering authors for how these things occurred. Instead, we're trying to reward them for being publicly aware, accepting of any errors that could exist, allowing others to check for them, and issuing appropriate correction, even if that's just how they talk about it in future work. And I think instead of one of our goals here is to undermine or change this belief that having for example, a correction of your work published, instead of that being damning or a blow to your CV, instead, especially when initiated by the authors themselves, this should be a mark of high scientific commitment to scientific values, right? The willingness to correct errors that are found and correct the scientific record. So just as the OSC 2015 paper was very influential because it was able to say that although definitions and so forth differ, but that 36% of studies replicated successfully, we don't know what the current rate of errors is in psychology. And the error program might be able to put an estimate on this with some caveats, excuse me, with some caveats and some issues around it. We could at least put a percentage on this. We've nearly completed 10 reviews so far, and it is important to note we have found errors in 9 papers. And these range in severity from very, very mild to ones that alter either the conclusion or the study's ability to answer that question in the first place. But this studying of not only the error prevalence, but also the error types is, yeah, of central interest to the paper, to the project. We're not merely looking to uh, check and correct 100 papers. That's a drop in the ocean. Instead, we are trying to get a sense of prevalence estimates, types, and intervene on yeah, error acceptance and correction. Okay. And then into the last stretch of the talk here. On the other side of the error-related activities we do, I spend a lot of time these days and with my PhD student, Lucas, working on trustworthiness assessment tools themselves. So right now, we have many methods that can increase the credibility of research that are highly effortful. They're in the top right-hand corner here, where the checks or the initiatives themselves are highly informative, they increase credibility, but they are difficult to do. Things like performing replication studies. And what we need more of, in my opinion, is things on the top left. Checks that are relatively informative and yet are simple to run, right? These are silver bullets to some degree, but they do exist. Loosely speaking, things on the bottom row are things that merely suck your time. They're not that useful. Things that are on the top are useful trustworthiness assessment tools with varying degrees of how much effort they take. I think it's useful to draw a distinction between the open science efforts on the top right-hand side here, which are I'm very much in favor of, and I've tried to contribute to over the last 15 years, replication and reproducibility and pre-registration, but acknowledge that they are very high effort credibility assessments. Rerun the entire study. I think we need to complement them with what seems to be emerging as what we could call forensic meta-science methods. Individual methods and checks like stat check, grimmer, tides, closure, sprite, recall, and try and avoid things like discourse, like on the bottom right, about how we just all need to publish less or to change the incentive structures while being very vague about how we would accomplish such a complex task. And it's not just me saying so that we should do this. It's the highest authorities like Cochrane. Cochrane introduced risk of bias, or others introduced risk of bias assessments a few decades ago when doing systematic review meta-analyses. And these are now required in Cochrane reviews, and they're becoming the gold standard elsewhere to say, let's not just synthesize all the evidence, we also need to know the quality involved. And in the very recent years, Cochrane has updated its policies further, but this information is only now coming down, I think, to psychologists, that trustworthiness assessment is a necessary prior step prior to risk of bias. So trustworthiness assessment differs from risk of bias in that it asks more fundamental questions like, did this study occur in the first place? Are the numbers reported in the manuscript mathematically possible? And if they're not at a certain rate, or it lacks certain things like this study has no ethical approval, then it should not be included in the evidence synthesis at all. And there are efforts to create umbrella tools that allow us to combine the results of other trustworthiness checks, like InspectSR, which I'm very happy to have contributed to. But InspectSR relies on individual tests and checks, things that are um, um, well-validated methods and sound implementations of them with accessible instructions and guides on how to use them. And all of this is currently lacking. And that's why our lab is working so hard to generate them, even to convey to others through the classes we teach through a book that hopefully we will eventually get around to writing, that there are different useful classes of these trustworthiness assessment methods, interpretation methods, like the correct interpretation of p-values, granularity methods, bounds-based methods, recalculation, and reconstruction methods. And with each of these, to come up with the methods themselves, sound implementations of them in R packages, and then more accessible training materials and easy to use web apps. So the last thing here I'll say is that, and this works a little bit better in a didactic setting where the audience can interact a little bit more. But a few years ago, I would have found it difficult to spot what is wrong in a set of a table like this, or whether these results were scattered around the paper. And better training in trustworthiness assessment and better availability of tools allows us to spot things better, easier, and faster. So, for example, StatCheck could tell you that that is not the p-value that should be associated with this T and DF, and that it looks quite like what the author, however and why ever, has replaced that significant 0.04, has replaced the what is possibly the real p-value of 0.09 with one of 0.04. This could be a typo between versions. It could be something more insidious. I'm less interested in that. I'm more interested in finding out how trustworthy the work is. Equally, if you had less information available, you didn't have the T and DF, you could still use an R package like Recalc, which I've written. It's in its early days yet, but it allows you to account for rounding and various analytic choices to run a small multiverse analysis to convert means, standard deviations, and ends back into p-values and effect sizes, and to say that p-value isn't possible. The p-value had to lie within this range. In other cases, we might be able to spot that certain means are not possible. Granularity-based metrics and measures like GRIM or Glimmer, implemented in R packages like Scrutiny, could tell you that, or using these web apps of ours, could tell you that mean isn't possible for that M. And it looks like it's been by accident or on purpose, doesn't matter, altered in some way. Other tools like bounds-based methods would allow you to quantify and visualize how extreme things like standard deviations are. I had no interpretation or sort of intuition of for standard deviations a few years ago. They were a thing that you kind of have to calculate, and you report it in an article for meta-analysis reasons, I guess. I felt very ignorant to them. And having spent a lot more time talking and thinking about standard deviations and understanding their mathematical range to develop the TIDES package, you can now quantify and say, well, these SDs are very, 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 very small for that scale. They are so small that almost every participant would have to give nearly the same response. And a plausible explanation for what has happened here is these have been mislabeled. They are not standard deviations, but they are standard errors. And this matters a lot when it comes to meta-analysis, because recalculating the effect size for this tells you it's very, very large, Cohen's d above 3.5. And this could severely distort a meta-analysis, but it could be caught earlier or by those meta-analysts by using packages like TIDES and like Recalc to find plausible explanations and do error checking like this. So where is all of this development occurring? Until now, until very recently, by many scattered individuals in a disorganized fashion. And now, at least in part, on this Slack workspace that I run, that I administer, forensic metascience in psychology, although the in psychology piece is light. That we've several medics and epidemiologists and other folk in there as well. What we have tried to do here is collect together our package developers of forensic metascience tools, sleuths who use these tools, and others to develop these methods, cross-validate them against each other, and we have already caught important errors in our own tools and corrected them. And error detectors must be doubly cautious about not introducing errors themselves, and to create more accessible versions of them, to create versions that are aligned with Inspect SR, and to generally do community building. So if some of these describe you or you have a strong interest, please feel free to reach out to me and join in, because we have a strong need for folk with, especially with R skills and other programming language skills, to continue developing these trustworthiness assessment tools and hopefully increase the credibility of future research. Thank you very much to my collaborators and my contributors for this talk, and I welcome your questions.